Okay, so today we're going to look at trig ratios this week. It's not as hard as what you think it's going to be. Alright, so let's take a look at what are these trig ratios we're going to take a look at. Right. We're not going to do every single one, we're going to take a look at three of them. We're going to take a look at sine, cosine, and tangent. So, first one is sine. So, the sine of an angle of a right triangle, again, we're dealing with right triangles, is equal to the ratio, the length of the side, blank of the angle, and the length of the blank. Okay? So sine is going to be the opposite side and it's going to talk about the hypotenuse. Okay, so opposite side of the angle and the hypotenuse. Cosine. So the cosine of the angle of a right triangle is equal to the ratio of the length of the adjacent side. So the side adjacent to the angle and the length of the hypotenuse again. And then the tangent. So the tangent of a right triangle is equal to the ratio of the lengths of the side opposite the angle and the length of the side adjacent to the angle. Okay? So here's kind of how we're going to remember it, okay? So, ka, toa. Okay, so sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. And again, these are ratios. So ratios are written as a, what? Fraction. Okay, so ratios are written as a fraction. So now, let's take a look. Well, what if I'm looking at angle A here? Okay? What if I'm looking at angle A? Well, if I'm looking at sine of angle A, sine says opposite over hypotenuse. So, looking at A, what side is opposite of angle A? Little a, right? Side A. So, big A's, big letters are going to be your angles. The small letters are going to be your sides. So small a, and what's the hypotenuse? C. We're just writing it as a fraction. Okay? What if I'm looking at cosine? Well, cosine says adjacent over hypotenuse. So what side, what leg is adjacent to A? Who knows what adjacent means? Or what is adjacent? No. No. Opposite is across. Right? So here's A, across, that's opposite. Opposite side of the room, front to the back, left to the right. So what's adjacent mean? Yeah, right beside. Okay? So adjacent here to angle A is what? B. Okay? Because C is going to be the what? C is the hypotenuse, okay? So the hypotenuse is going to be C then. So B over C. And then if I'm looking at tangent of A, well, that's opposite over adjacent. Again, what's my opposite from A? Little a, right? Adjacent is going to be B, okay? Yes. This and this, yes. O and A. Sorry. Opposite and adjacent. Questions on that? So we're just finding what side lengths, and again, we'll do another one of these, but they're going to have side lengths in here. So what side lengths we're going to look at. What about B? So if I'm looking at B, now my perspective changes. Okay? my perspective changes based on where I'm at. So now if I'm looking at sine of B, well, what's the opposite of angle B? No, little b. Opposite of big B is the little b. What's the hypotenuse is still C. What about cosine? Adjacent over hypotenuse. So what's adjacent to B? Well, C is the hypotenuse, right? So C is going to go in the bottom as the hypotenuse. A is going to be the adjacent side. And then tangent, opposite of B is what? Little b. Adjacent to B is A. So B over A. Okay? Yes. Yeah. Alright, take a look on the back. So the back's going to basically be the real, this is what basically what we're going to be looking at. Okay? So again, if I'm looking at this, looking at SOHCAHTOA, so again, I'm looking at sine of angle A. So if this is my angle I'm looking at right now, sine says opposite over hypotenuse. What's the opposite? What's the opposite side? 5, 12, or 13? Opposite from A is what? 5. Hypotenuse from A is what? 13. What about cosine of A? Cosine says adjacent over hypotenuse, so adjacent from A is what? 12. Hypotenuse is 13. What about tangent of A? Opposite over adjacent. So opposite of A is what? 5. Adjacent is 12. Good. Now we're going to look at B, angle B. Again, this relationship changes. Okay? I think it's a little easier putting numbers on there. So sine of B, opposite over hypotenuse. Opposite of B is what? Opposite of B is what side length? 5, 12, or 13? 12. Hypotenuse is? Cosine adjacent to B is what? 5. Hypotenuse is? Tangent opposite to B is what? Opposite is 12. Adjacent 5. Okay? Now, what do you notice about these relationships, these ratios? What do you notice about them? They're all the same numbers, right? Okay? So, looking at sine of B and cosine of A, it's what? It's the same ratio. Looking at sine of A and cosine of B, it's the same ratio, right? And then what happens to tangent? Tangent just gets flipped, okay? Now, here's what I want to look at. If I want to take this, so grab a calculator, and I type in this ratio, 5, 13, 5 over 13. I get this decimal point. 0.3846. And it keeps going, we're just going to round it to 4 spots. Okay? If I look at the second one, 12 over 13, I get 0.923. We'll round that up to a 1. And then 5 over 12, 0.4167. Rounded up. Okay? Now, so just like we talked about before, all these right triangles okay, have special relationships. So that's why we can do the Pythagorean theorem, okay? That's why we can do some of the other stuff we've done. So that's why these trig ratios work, all right? So take a look on your paper, the other little paper, so this guy right here, okay? So take a look on that paper, and what I want you to do so you're going to look on this chart, and you're going to go down. You're going to go down sine. Let's go down sine and find 0.3846. Is it on there? Yeah. It is on there? No. Let's see here. So these are the angle measures. So if I could find this ratio, 0.3846, okay, it would basically tell me what that angle measure is going to be. Okay, does that make sense? So that's what we're going to end up getting to next week. Right now, we're just worried about putting the numbers in the right spot. Okay, so pretty basic this week. Get the numbers, put them in the right spot as the fraction. Next week, once we make sure we have the numbers in the right spot, then we can find missing angles. We can find what these two angle measures would be. Okay? We can figure out if we have a missing side length, but we have the angles, we can find missing side lengths the following week. Okay? So those are the two things. So basically we're going to be on this 3 weeks. This week we're doing the numbers, putting it in the fraction. Okay? The following week we'll be doing finding side lengths. Following week we'll be finding angle measures. Okay? So that's what we're kind of looking towards in the future here. Okay? The other thing you can kind of look at is on the bottom. Those of you who may take Algebra 2 could get into situations like looking like this. So if I look at, let's make a 30, 60, 90 triangle. Okay? So here's I'm going to use this line right here. So here's 30. So this angle right here is 30, right? If I come straight down and make that 90, this has to be 60. Okay? So what happens is everything is kind of based off of this. It's called the unit circle. Okay? So in Algebra 2, you can do trig just based off of this unit circle. Okay? So if I'm looking at this and I want to have sine of 30, sine of 30 should be 1/2. Just divide that. Okay? Cosine of 30 is going to be the x value. Square root of 3 over 2. Tangent would then be 1/2 over square root of 3 over 2, which then converts into 1 over square root of 3, which then converts into square root of 3 over 3. But okay, so you can take this a lot further. So that's why I want to show this to you. If you take an Algebra 2, depending on what you take, you could end up seeing some stuff with the unit circle and finding sine, cosine, tangent. But now you've at least used sine, cosine, tangent on the basic triangles. Okay? So